What is up, winning team? And hello to those of you who are interested in the science stuff here, because today we are going to be talking about the fact that there is actual evidences, there are actual scientists speaking up about the fact that some of the things in science scientists know are lies, but they have continued those lies for a particular reason. And I've decided to include this as part of my Fourth Dimension series. If you want to know all about that, it's all going to be linked to the description box below, including the book that we are currently reading, which is Beyond the Veil, Exploring the Bubble Theory and the Fourth Dimension. Go and check that out. We're about to go into chapter, I don't even know what today, chapter 13 today, which is what I was planning on filming until I came across this particular video by a scientist called, what is her name here? This is all new, you guys, to me, so hence why I don't know more. Sabine Hossenfelder. So Sabine Hossenfelder basically made this video. It's titled, I Was Asked to Keep This Confidential. I'm going to put this also into the playlist. I think I'll put it after this video so it makes sense why it's there. But essentially, in the video, she's talking about a letter that she received. This is when the algorithm goes crazy. Listen, this morning I woke up and God was like in my algorithm, because I was like, the stuff that popped up, and like I said, I was supposed to be working and I was supposed to be preparing for work, and then work got cancelled last minute yesterday, and now we know why, because I needed time to actually do some stuff. Anyway, so I watched this video, and in this video, she's being advised of an email that she received because she criticized in a 2-page paper that we are about to read science. She's a physicist, and her issues are surrounding the fundamentals, the elemental particles, etc., things that we've been talking about. So I thought I was going to continue with the rest of the book next and come to this afterwards, but I felt like I wanted to do this organically, and organically, this is when I came across this. There ain't no way I'm not reading this today. So y'all are going to be here for this. So we'll get into all of this, and you'll understand very quickly why I'm even bothering with any of this. So she's got a 2-page article. I will try, actually, the article's linked in the video that I'm going to add, so you can go and find it for yourself. She's actually made it free to the public. And I believe it's because, again, for a lot of us, which I so resonate with this, you get to a point where it's like your morals and the truth that you're being faced with, like you have to make a choice that, am I going to continue to like speak the truth when I'm and be authentic and be honest, or am I going to be a coward and hide the truth or lie for other motivations, which is exactly where this is going. So hear me out. We're just going to read. This is my first time reading it, although I saw in the video she reads the letter with response to this from the scientific community. So go and check that out for yourself afterwards, because it's really interesting. Let's read through this. The title is Science Needs Reason to be Trusted, Sabine Hossenfelder. That we now live in the grip of post-factualism would seem naturally repellent to most physicists, but in championing theory without demanding, let me just read this whole phrase again. That we now live in the grip of post-factualism would seem naturally repellent to most physicists, but in championing theory without demanding empirical evidence, we're guilty of ignoring the facts ourselves. Oh my gosh. I feel like I'm just going to say it now. This is probably going to end up happening over multiple videos, because I'm going to have to commentate. And then once this is done, we're going to go back to finishing the book. There's just so much. I didn't know, guys. I didn't know. I knew that science had, there was reasons I didn't trust science. I didn't know the detail, and nor did I have like an actual example of the things that she's talking about. I just had a hunch, you know what I'm saying? And so this is why this is interesting. But already she's suggesting that without demanding empirical evidence, which is again something we've seen multiple times in the book. He keeps saying, what do we need in order to prove this bubble theory concept, the fourth dimension? where there's a need for empirical validation, a need for empirical validation, a need for empirical validation has repeatedly come up in this. And it's right, because again, the whole concept, and this is why I don't mind mentioning God alongside all of this, the whole reason that people trust in science, and the whole reason that science is seen as the factual, truthful, whatever, and then the spiritual things or the godly things is seen as make-believe and unprovable and lacking in evidence, is based on the fact that we apparently can tangibly prove the science, right? Which physics is the most physics, hence physical. It's the most physical and should be the most physically observable of the sciences, right? You might not be able to see a plant photosynthesizing, right? In the same way you might not be able to see an atom. However, you absolutely can see and feel in your car when you're traveling at 60 miles per hour, right? So physics is supposed to be the physical one. So there should be the most empirical evidence here. And this is even why I like physics in the first place, because I'm like, you can literally feel and see and use and do. I'm so sad. The men outside are taking down the scaffolding. I'm going to miss them. What am I going to look at out the window now that they're gone? Oh, they're taking down this. Anyways, I need to focus on it's okay. It's a sign that I need to focus on more important things. Anyways, you guys, let's just get into it. But you get what I'm saying here? So, this is going to be so good. Yeah, this is probably going to be multiple videos, and it's fine. We're going to leave it all in the same playlist. Told you guys, we're going to end up having to go off on... Anyway, I'm a theoretical particle physicist, and I doubt the value of theoretical particle physics. I love to see a woman in freaking science with some freaking balls. I love it. That's awkward already. I know, but it gets even worse. I'm afraid the public has good reasons to mistrust scientists. And sad but true, I myself find it increasingly hard to trust them too. Trust the science. Remember all the trust the science people? I wonder what kingdom they're working for, but we're going to come back to that. In recent years, trust in the science has been severely challenged by the reproducibility crisis. Oh, so, okay, I'm assuming this problem has predominantly fallen on the life sciences, where it turns out many peer-reviewed findings can't be independently reproduced. Oh my gosh. Lord, thank you for me finding this video today, because this is the proof I needed to shut down and shut up the naysayers when I'm telling them they can't trust in this stuff, and that the fact that they think just because it's peer-reviewed articles and whatever, I'm like, but the point is, are these reproducible things? How do you know? Because you haven't run the tests yourself. You haven't done the science yourself. So how are you so sure that these are the people to be trusting in? But you're just trusting in them because you've been programmed to do so. Oh my gosh, I'm so happy to be here. So attempts to solve this have focused on improving the current measures for statistical reliability and their practical implementation. Changes like this were made to increase scientific objectivity, or more bluntly, to prevent scientists from lying to themselves and each other. They were made to re-establish trust. So people have been actually lying on purpose, is essentially what she's saying. And they've had to put things in place in order to actually make sure that when people are saying we produced this, they actually did. Because I said to you guys, I've said it multiple times in this series, which is why I felt this makes sense to add in here, that the whole premise of you doing a scientific report, I've not done like proper high-level scientific research, but I have done a scientific research paper that I did as part of my accredited Royal Society of Chemistry accredited degree, as I said, right? And for doing that, the whole premise is you write, it's so long, these papers are so long, because people are supposed to be able to understand every level of how you, based on the standard principles, which we're going to come back to all of that as well, and what's already known in science, and why you're questioning it, what gives rise to why you're even questioning or supposing something in the first place. Then the method of how you did it. Why do you give your method, and why do you give all the details? Why did I have pages and pages and pages and pages and pages of graphs of all my calculations? Because the idea is that if what I'm saying is true, then other scientists should be able to go and do exactly what I said under the exact same conditions. I should have just had my research paper with me. Would have made it so much easier to explain what I'm talking about. Where is it? Hold on, everyone. Okay, so I found it. I did a whole video, by the way, explaining about my research if you really want to hear about it. And it's about computational chemistry predictions of IR and UV vis emission spectra of small organic molecules. So, okay, so here's the thing. I'll show you guys exactly what I'm talking about, right? This is all done for a reason, and I learned that for a reason, right? As you see here on the front page, I've had to put through an abstract, an index, a list of all contents, all tables and figures, equations, abbreviations, acknowledgements, obviously. Then I have to do the full introduction, computational chemistry background, applications of computational chemistry, ab initio methods in quantum chemistry, the Schrodinger equation, its use for the prediction of emission spectra, yada, yada, yada. So I'm giving the basis level of why I'm doing this, right? Then methods, of which I have to show exactly what I was doing and exactly how I did it. So I'll just give you guys an example of this so you can see the to and from. I'm doing this for a reason, right? I'm trying to show you that this is how we're supposed to do things to make things valid, right? So where are we? Oh my gosh, there's so many pages here. Yada, 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 yada. Okay, so this is my method, right? You can't really tell because I've printed, this version is printed in black and white. But here you can see I've listed all the equations, the basis sets, the levels of theory, right? And then I've got the molecules that I'm going to use that I've drawn on an online software. I'm really sad these guys are leaving. And then you can flick through. So that means anybody can go and take this paper and they can go and put these basis sets and these levels of theory. And if my work is not lies and whatever my conclusions are, they should get the same results as I did. So I've got all of these pages and pages in the back. Literally pages and pages and pages and pages and pages of me doing of all of my spectra, right? Literally pages and pages. Okay. So why am I showing you all of this and why have I gone to this extent? Largely because there's no way I'm going to edit any kind of, you guys know I don't edit my videos really like that. So there's no way I'm going to edit all of these examples onto the screen, and why not just show you with my own work that can't be copywriting for anything because this is my own stuff. And then I show what I would do for my future work. We'll see an extension of my basis sets, extension of my levels of theory. I explain my results, yada, 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 right? So this means somebody else can take this paper, right, as it is, and they can go and not only check the validity of my results, but they can so by confirming it, they can do it themselves and they can see where they can go next. And that's how science is supposed to work, right? So I would just like to say that I did indeed, as I've said before, I did actually replicate the same as the other considered values that exist out there based on other people who did the similar types of research. So that's why this stuff matters. This is why I really am so passionate about all of this and why I'm saying it, that if scientists are saying that this reproducibility crisis thing is a new concept to me, completely new concept. If she's saying, oh, let's just continue with what she's saying. But I hope you guys can kind of understand with like a visual. I know that I don't add visuals and things. I know one day when I can afford one, I'm just going to pay for somebody to do it because it's not my bag, okay? Okay, explanations. Okay, perfect. So she works, okay, where are we? We're not there. They were made to reestablish trust, right? So that's the trust that we have. The trust that I say this, if I tell you guys that this is what the infrareds, the molecules in outer space are based on this because of my research, that's supposed to produce trust in you. But we're just trusting, suspecting that people are doing obviously much higher levels of work than this. I actually have another person's PhD book right here that I could actually, anyway, we'll just leave it. I work in theory development. So where are we? The reproducibility crisis is a problem, but at least it's a problem that has been recognized and is being addressed. From where I sit, however, in a research area that can be roughly summarized as the foundations of physics, cosmology, physics beyond the standard model, the foundations of quantum mechanics, I have a front row to a much bigger problem. So this isn't even the biggest problem. I work in theory development. Our task, loosely speaking, is to come up with a new, somehow better explanations for already existing observations and then make predictions to test these ideas. I see the issue here. We have no reproducibility crisis because we have no data to begin with. All presently available observations can be explained by well-established theories, namely the standard model of particle physics and the cosmological concordance model. But we have a crisis of an entirely different sort. We produce a huge amount of new theories, and yet none of them is ever empirically confirmed. Let's call it the overproduction crisis. We use the approved methods of our field, see that they don't work, but don't draw consequences. Like a fly hitting the window pane, we repeat ourselves over and over again, expecting different results, which in and of itself is the definition, the actual definition of insanity. And I've told you guys this before. Scientists, we're all technically insane, because doing the same thing over and over again, expecting different results in and of itself is insanity. But unfortunately, if you're doing an experiment that's expected to only happen 1 out of 1 million times, guess what? You're going to have to do it at least 1 million times. And that's just statistics. That's just a statistic. So really, you probably want to do it about like 3 million at least, or 5 million to guarantee that it happens at all. Right? So I've told you that there's an interesting line between sanity and insanity as a scientist, because technically speaking, going outside of what's already believed and speaking out or looking at things in a different way is kind of making yourself look somewhat insane. Even you could argue that Jamil, who wrote this, you could argue he's insane for even thinking of another theory, right? Especially when we're talking about things that are not observable. We're going to leave this here and we're going to continue the rest of this article. But we've got some pretty shocking things that we've said already. So just buckle up, everyone, because this is going to get juicy. We'll continue with this. It's all going to be in the Dimension playlist. I might have to I don't know what, I'm going to have to change the name slightly because this is going off the rails now. And we will, after this, go back to this. Don't you worry. Yeah, so now she's talking about the crisis of doing different things, expecting different results. Some of my colleagues will disagree we have a crisis. They'll tell you that we have made great progress in the past few decades despite nothing coming out of it, and that it's normal for progress to slow down as a field matures. This isn't the 18th century, and finding fundamentally new physics today isn't as simple as it used to be. Fair enough, but... And if you want to see where that goes, you're going to have to come find us in the next part. It's all going to be linked all in the description box below, including the book, including the series, including everything that you need. This video, her video of her response, I'm going to put at the end of all of the videos with me reading through this so that you have the context of what she was being criticized of. Because that email is insanity when you guys get to see it. Anyways, if life's a game, it's pay to win. God bless you all. God loves you. I love you. And I'll see you guys in part 2. Goodbye.